Hello students, parents, family, and community members. I'm Dr. Kelly Baudo, Assistant Superintendent for the Buffalo Public Schools, Division of Curriculum, Assessment, and Instruction. It is my pleasure to introduce you to the BeEnriched television initiative, where students will have the opportunity to participate in instructional lessons and virtual field trips. The program is designed for students in the Buffalo area from kindergarten to grade 12, and the instructional lessons are designed and delivered by Buffalo Public School teachers. The lessons support literacy, history, STEM education, and the arts. Culturally responsive lessons will be included along with virtual tours of Buffalo's cultural institutes and landmarks. There are a total of 40 half-hour segments. It is our hope that you can tune in every day, Monday through Friday, to immerse yourself in these learning experiences. If you miss a class, no worries. We will be repeating these throughout the next several weeks. Also, each course and description will be archived and can be viewed at any time on BeEnrichedBuffalo.org. We would like to thank the people who have made BeEnriched possible. Those include Harmac Medical Products, the Community Action Organization of Western New York, and KeyBank in partnership with First Niagara Foundation. Without the three organizations, this programming could not be possible. Additionally, we would like to thank Buffalo Schools Superintendent Dr. Kreiner Cash for his commitment to the students and families of Buffalo, ensuring that there was support for the BeEnriched program. We would also like to thank Dr. Darren Brown Hall, Chief of Staff, Ms. Ann Botticelli, Chief Academic Officer, and last but certainly not least, the dedicated school teachers who have prepared and taught the enriched lessons. Thank you and enjoy watching these special shows.
Hello and welcome. My name is Dr. Minervino and I'm a science teacher at City Honors School in Buffalo, and today I want to share a lesson with you about air pressure and its connection to weather. We've been talking about weather since you were little kids. From the time you were in kindergarten, you were looking out the window and talking about the weather. If it was a rainy day, a sunny day, if it was cold or warm, but you never probably really gave much attention to the importance of air pressure. So today we're going to show you the connection of air pressure to weather. We have some objectives that I would like you to get from this short lesson today. The first one is that you will be able to describe Earth's atmosphere and the air that is in our atmosphere. I want you to be able to describe differences between a day that has low or high atmospheric pressure, and then identify an instrument that scientists use to measure air pressure. You've probably heard of a thermometer, which is used to measure air temperature, but you might not know what is used to measure air pressure. I would like you to be able to recognize the significance and the importance of air pressure and how it really is acting on us constantly every single minute of our lives, but we take it for granted. And lastly, I would like you to be able to locate and evaluate local data related to weather. And this is something we can very easily get through in our short lesson today. Here are some guiding questions. I would like you to think about these as we go through the three segments of today's lesson. I want you to think about how is weather characteristically different on a day with low air pressure versus high air pressure. I want you to think about how air pressure can be pragmatically measured, and how can trends in air pressure be used to forecast future weather for a local area. That's important. It might be a day where you have a baseball game and you wake up in the morning and it's dreary out, it's rainy, it's cloudy, and you might think that the game is going to be canceled. But if you know how to interpret data with air pressure, you might be able to predict whether or not it's going to clear up and you'll be able to play your game. First, I want to have you watch this very short video clip of about 20 seconds showing us the significance of air pressure. Okay, please watch. So you saw that, and you probably have a lot of questions about it. It's pretty cool to see that. You think about all the different materials that were used, a balloon, a plastic bottle, a straw, and some liquid. And it was kind of like magic how it went from one vessel to another. It went from the pop bottle to the glass. And was it magic? What happened? Well, these are probably some things that you're thinking. How did the liquid move through the straw? What caused the liquid to move? And what is pushing on the balloon to cause that water to move from the pop bottle into the cup? And those are good thinking modes to have. Well, do you have any ideas? The lesson's about air pressure. So it's probably going to be related to air pressure. If you think about a balloon, you've probably played with balloons. You blow them up and then let them go, and they go all over. That air is in a balloon. It's captive in there. And the pressure is going to push it down, push the water through the straw, and fill the glass. It's going to keep going until the balloon empties of air. So air is something. A lot of times, you have a hard time understanding that air is matter. It's a gas. Gases are not insignificant. They can't just be thrown out and discounted for the value that they bring. They have, all kinds of different elements that make them up. They have masses, and so they do interact with our physical world. So, well, what is air? When you breathe in, a lot of people know that you're breathing in oxygen, but what you're actually inhaling is very little oxygen, okay? Air is a mixture. It's a heterogeneous mixture, which means there's a lot of different things in there. The thing that's most important to us as humans and as animals is oxygen, but that's a small fragment of what you're actually breathing. In the reference table, on the cover of the reference table, we can see the elemental composition of the troposphere, which is the lowest level of the atmosphere. And you can see oxygen is up on the top, probably because it's most important. It's only 21%. It's not the most important thing. It's not the most abundant item, but it is the most important to humans. But if you look down here, 78% of what you're inhaling is nitrogen. 1% is other. So these are the things that air is made of. This is the heterogeneous mixture of gases that make up the air that you're inhaling. So data is really important to be organized really neatly and orderly. So this is one example of how that data can be displayed to you in a data table, or you can also represent it as a graph, a pie graph, and you get the same information a little more visually. You can see that oxygen is one of the slivers. The biggest chunk there is nitrogen, and there's a small sliver that includes all the other elements that make up the atmosphere. So all of those gases together are what make the atmosphere. Atmosphere is not just something that we have on Earth. There are several atmospheres in our solar system. Some moons have an atmosphere, some planets have an atmosphere, some do not. The determining factor is usually going to be the mass of the object. Whether or not it has a lot of mass, it'll be able to hold on to that gas. If it's not very massive, the gas will escape into space. But Earth has a really good, healthy, hearty, thick atmosphere that allows us to live the way we live. So if you look at the diagram here, you can see that envelope of air surrounding Earth is our atmosphere. The image doesn't really do it justice to how thick it is. When you think about the air and you look at this picture, you think, okay, it's, a nice little buffer, a padding around Earth, but it actually is quite sophisticated in terms of the different properties of the atmosphere. It's quite thick, much thicker than it looks in that picture. A lot of the important data related to the atmosphere is also found in the reference table, which you see on this graphic here. And if you read right here in the middle, it says it extends to 600 kilometers. That's how thick the atmosphere is, 600 kilometers. So if you're standing down and you look up, 600 kilometers up is air that's above you, that's pushing on your head, pushing on your shoulders, pushing on this table, okay? The temperature of the atmosphere changes as you go up. The amount of air pressure changes as you go up, and the amount of water vapor changes as you go up. The water vapor concentration decreases, the Pressure decreases as you go up. Temperature is not as straightforward. Temperature changes. If you look at this line, it's very squiggly because in different regions you will notice that the temperature is either increasing or it's decreasing. That is all that we're going to say about our introduction on the atmosphere and air of our planet Earth. In the next segment, we're going to be looking at some meteorological instruments that measure air pressure and talk about some other factors. Thank you. Please hold for the next segment. Hi, welcome back. I'm glad to see you're still stuck around for the second half of our lecture today on air pressure. I have something in front of me right now that you probably have never seen before. It is very unusual looking and probably catches your attention, especially if you were in a house and you had the opportunity to watch it for a few hours. If you were at your grandmother's house visiting and you walked in the door and it was a nice sunny day, this is what you would see. Let's say that all of a sudden a storm came in. It got cloudy out, it got windy out, maybe some precipitation started to fall. You would notice miraculously that this weather glass would start to shift a little bit. The dyed water in this vessel would start to extend up the stem, and possibly, if it was a really severe weather and really low air pressure, it would actually discharge out the top of this vessel. Right now, today in Buffalo, it happens to be a relatively nice day. The air pressure is kind of high, so it's not really extending high. This is kept in my classroom at City Honors, and my classroom has no windows at all. I know it's like torture for me, and we can't look outside and see how the weather is. But by looking at this, we can get a sense of how bad the weather is. We can get a sense if it's really snowing hard, if it's really windy out, by looking at and tracking the path of this liquid water. Okay? So this is a real primitive way of measuring air pressure. There are more sophisticated and advanced ways of measuring air pressure out there. A meteorologist working for a weather station would not be using this probably to forecast the weather. Maybe it's a nice little decoration sitting on his desk, but probably not going to be using it to give you the weather report. They want to use something a little more exact, some numbers. Numbers are really important when you're talking about weather. When you want to compare how warm it is one day versus another day, you want to be able to say more than it's hot out. You want to be able to say that it's 90 degrees out or it's 88 degrees out. There's a difference there. So we all know that a thermometer is used to measure temperature. It gives us numbers, a metric that you can use to record how warm it is. Depending on where you live, you might use Fahrenheit, you might use Celsius, and in science research laboratories, you might even use Kelvin as a measurement. If we look here, we see something that looks like a clock. This is a more modern, practical tool that's used to measure air pressure than our weather glass. Okay? This is called a barometer. And a barometer is a scientific instrument that scientists and meteorologists and regular people like you and I can have in our homes to tell what the air pressure is. Look at this really closely. I want you to look at this device. It looks like a clock because there's a lot of numbers and there's a hand on it. But something else that you see are pictures of stormy weather, nice sunny weather, and kind of in-between weather. And the needle is going to point to the numbers to tell you what the air pressure is. Depending if it's a low air pressure, these numbers in the 900s are low, 970, 980, 990, you can see it's showing you a picture of clouds and stormy. That tells me that low air pressure is going to be poor weather. As the hand goes higher and higher and higher, over 1,000 into 1,030, 1,040, we see bright sunshine. That means high air pressure is good, favorable weather. Okay? That's something you really got to remember drill into your head. Low air pressure, bad weather or poor weather. High air pressure, good weather, clear weather. The kind of weather you'd want to have a picnic or a baseball game with. Okay? So, I think that this is a topic that can be very visual, okay? When you think about high pressure and low pressure being good weather, low pressure being poor weather, these are some images that should come to mind. Look at that beach. Who wouldn't want to be there? That is like paradise in a picture. It looks like it's warm. It looks like it's clear. It looks like it's calm. Doesn't look like there's any chance of rain in the future. It'd be a good day to be at the beach, to be at a baseball game, to be at a picnic, to go for a hike, any of those great things that we all like to do, okay? Second picture is a picture of what should come to mind when you think of low pressure. It's like, oh, do you really want to be there doing things outside? No, it's going to really ruin your baseball game. Forget about a picnic. It's not going to be fun to fly a kite. None of those things are going to be really good in this kind of weather. Okay? So this is what you should be thinking of and visualizing when you think about the differences between high pressure and low pressure. Good weather, poor weather. All right? That's really important. Look at the two pictures. Where do you see a lot of trees that are bent over almost because of the wind? Low pressure. Where do you see a lot of clouds? Low pressure. Where do you see more of a chance of precipitation? Low pressure. Where do you see calm, clear skies? High pressure. All right. So let's put all that information into a T-chart. Boom, magically appears. High pressure, good weather. Low pressure, bad weather. Precipitation, yes, it's probably going to rain in a low pressure system because remember, that's poor weather. Winds, strong winds. Very, very strong winds. Usually if there's a storm coming, you can feel wind. Sometimes I'm outside doing yard work and all of a sudden I notice it's getting kind of windy when I'm, watering a plant or pulling a weed or doing something, and I look up and I see clouds. Usually, right before a storm, it's going to get a little windy. The wind direction, which we haven't really talked about yet, but we will soon in a future lesson, the wind direction is counterclockwise and towards the center, and clouds, yes, there's lots of clouds. In a high-pressure system, it's just the opposite. It's the antithesis. Very low chance of precipitation. There will be very weak winds that might be considered calm. There will be wind direction that's opposite of a low-pressure system. It's going to be clockwise and out. And there might be some clouds, but very few. Now, back to our barometer. Our barometer is great because it's kind of like giving us a clue as to what's going to happen in the future. If you are watching your barometer at lunchtime and you notice that it is right here in the middle at 1,010 millibars of air pressure, and when you finish lunch an hour later, you notice that it's going down. Ooh, that's not good, because that means that the barometric trend is going down. The barometric pressure is dropping. Air pressure is going down. That means the weather quality is going to go down with it. That's not good. So that's why it's important to know how to use a barometer if you have one at home. So if you hear the barometric pressure is going up, the air pressure is going up, that means the weather is going to be improving because the millibars are going higher. We're going to get clearer skies, less chance of precipitation, and all those favorable types of weather properties. So, bad weather is low pressure. So all of these storms are low pressure systems, low pressure weather. Hurricanes, tornadoes, thunderstorms. Okay? I'm going to show you a real short video clip of a hurricane and see what gives you clue that it's low pressure.
Keep going. All right, we got to move, guys. We have to jump the fence. Okay, we got to jump on.
Well, hopefully you were able to see lots of wind, lots of rain, and flooding. Those are all signs of low pressure. We're going to take a break and come back for our third section. In a minute, we're going to really do an awesome demonstration to show you how significant air pressure is on us, humans that live at sea level on Earth. Thank you. Welcome back to our final segment today on air pressure. One of the things I think is going to make this really helpful to you is to compare air pressure to water pressure. So I brought up a picture of the ocean, a cartoon image, but you get the point by looking at it. As you go deeper and deeper down in the ocean, you imagine that there's more and more water pressure acting on the fish, or even a submarine, if you had a submarine. If you think about a submarine, the glass is really thick. It's made of thick metal walls. Why? Because there's so much water pressure acting on the things that are down there deep in the ocean. The items that are close to the surface, there's not as much. Think about Earth and think about us. Where are we located on this diagram? If you are a human, and I'm a human, and we're all humans, and we're at the surface of Earth, all of that air is on top of us. So it's kind of like we're at the bottom of the ocean because there's so much air on top of us, above us. So, but you don't feel like it because, as you're moving around, air is just there. But it's really quite significant. So I have a demonstration that's going to do a good job of showing you how significant air pressure is. It's a challenge. If we have a ruler here, and if I just apply a little bit of pressure to it with my finger, it's going to do what? Yep, it's probably going to fling up and fall off the table. So let's show you what that looks like. Flings up and flies off of the table, just like you would expect. Well, I want you to think about what you could do to stop that ruler from flinging up, okay? If I wanted it to stay held down while I fling it, what are some things I can do? Tape it down? Yeah, I could take some tape, tape it down, and it would probably stop from moving up. Let's try that. Put a little bit of green tape on that green ruler. Green is my favorite color, and it's not moving. Okay, so that does work. All right, cool. What about a brick? Well, we can put a brick on it, tap it with my finger kind of gently. It's not moving. Great. What about some of those big textbooks that we have? It's not moving. Great, 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 great. Well, what if I wanted to get really clever, okay? And instead of just tapping it with my finger, I wanted to hit it with a baseball bat. But not just tap it, swing it as hard as I could. What would I need to do to keep that ruler from flipping up? Put more bricks? Well, maybe that would work. More textbooks? Yep. Staple it, screw it down, use some nails, use some super glue. I've heard all of these great ideas of things that you could try. I'm going to put on safety goggles for this next part of the lesson because it might get a little dangerous. Don't try this at home without supervision. Well, you would probably be a little surprised looking at this regular, normal ruler and a regular little baseball bat to figure out how air pressure can be used to keep it held down. I'm going to need air pressure and one sheet of newspaper to hold this ruler down. Okay? So, I'm just making sure that the sheet of paper is nice and smooth on the ruler. Thinking about this, how am I going to hit it? I want to use a lot of my muscles and energy to hit it as hard as I can to show you how strong air pressure is. Okay? So I want you to focus down on this and think about this while I hit it. So 1, 2, 3. It held it down. Okay? It didn't go flinging up. Look at how good that broke. Okay? Why? Well, if we try it again, and I'm not going to use the baseball bat. I'm going to just use my finger. I want you to look at the newspaper. The newspaper is holding it down. The air above the newspaper is pushing down here. It's pushing down here. It's pushing down here. Without the newspaper, the only air pressure that's acting on the ruler is directly above it. Here, here, and here. But when I put the newspaper on it and I cover it up, the air pressure all around this table is pushing and holding that ruler down, keeping it from flinging it. I want you to imagine, I know that the ruler did fall off of the table, but I want you to imagine what would happen. I'm not going to do it, but if I hit this as hard as I could without the newspaper, it would go flying across the room. Okay, so we're going to hit this as hard as we can with a baseball bat to show you that the air pressure above this sheet of newspaper is holding the ruler down. Remember, when I just flicked it with my finger without a sheet of paper there, it was catapulting around the room, and let's see what happens here. Okay, so I'm going to hit it as hard as I can. Wow, look at that. The ruler is still up on the table. Why? It wasn't because of books, bricks, nails, screws, tape, or glue. It was because of the air above this sheet of paper. It's not the mass of the paper. The mass of the paper is insignificant, but air pressure is very significant. Okay, let's review some of the things that we talked about today. We talked about barometer being a scientific instrument that's used to measure air pressure. We talked about the difference in how air pressure looks on a day that has high air pressure and low air pressure. High air pressure is good weather. It's going to be clear, calm, dry. Low air pressure day is going to be cloudy, rainy, okay? Poor weather. Please keep this in mind when you're learning about weather. It's not just temperature. Air pressure is very important. I thank you for joining us today, learning about air pressure, and hopefully you have a better appreciation for the connection of our atmosphere and air pressure with weather. Thank you.